Hello everyone, welcome to my channel. In today's video, we will solve a DSA question that is search a 2D matrix. Let's see what is question saying. In the question, given a matrix that size is m cross n and with two properties. The first property is saying that each row is sorted in non-descending order. And second point, given that the first integer of each row is greater than the last integer of previous row. Okay, then after we have a target integer, we have to return true if the target is present into the matrix. If not present, we have to simply return the false. So in example 1, given a matrix input and target is 3, so 3 is present, that's why in output you can see true. Let's see the approach, which approach we can follow and how we can solve this question. So for example, we have this matrix and the target is 11. In the question given that this is shorted and also given that each row first element is greater than the previous last element. Okay. So suppose we have to given a target 11. So firstly we need to check 11 will come in which row. Once we find the row, then that particular row is already sorted. We can perform the binary search on that particular row. Then after we can got our required answer. So in the first row, all data is already sorted. So we can do simply first we will check in which row it exists. So firstly we will check is 11 less than 1? No. So we will go to the next row. Is 11 greater than 10? Yes. Then again we are checking is 20 is 11 greater than 23? No. It means the correct row is this one. Correct row is 1. So after we got this row, we have 10, 11, 16 and 20. So we will do the binary search in this second row. By the binary search, we can simply find is 11 present into the this row or not. So just go to the code. So here what I am doing, I have declared a row initially at is 0. Then I am taking a loop. It will run from 0 to size, matrix of size. So here the given matrix is 3, for example. So here it will go from 0 to 0 less than 3. And here I'm checking is first value of this, sorry, this value like 1, 10, 23 is less than target. If yes, then I'm updating the row with the value I. If not, not less than target, then I'm simply breaking the question, breaking from this loop. Once we got the row value, then we will perform the binary search on particular row. So as you can see, here is the binary search portion code. So I'm declaring low is equals to 0 and high is matrix row dot size minus 1. Okay, so by this we can got the high, and we are taking mid as a initially as a 0, and we are taking a while loop that will go from go with the condition until low less than equals to high. So mid we are calculating. Once we got the mid, we are checking is row mid is equal target. If it's true, then we are returning true. If this condition not satisfied, then it will go to the else if portion. Here we are checking if not equals to not equal to target, then it might be greater or less. So here we are checking the less. If less, then we are doing low equals to mid plus 1. So here we are updating our low, and if both condition not satisfy, we simply just updating our high. By this At the end, we are returning false. If these condition also not satisfy, it means we don't have that target value into the given matrix. So just simply returning the false. Let's run this code. So here both test cases has been passed. Now coming to the time and space complexity. So here we are taking a loop that is taking order of n time complexity. Here n is the number of row. After once the row we got, then we are performing the binary search. So here for the binary search, we are taking order of log n time complexity. Here n is the number of column. So the final time complexity if is order of n, sorry, order of m. Here m is the number of row, and here binary search taking order of log n. So total time complexity will be order of m plus log n. Now coming to the space complexity. Here we are using row variable, then we are using low, high, and the mid. So these are taking only order of one space complexity. We are not using any extra space rather than this. So the final time complexity is order of m plus log n. Here m is the number of rows and n is the number of column and the space complexity of order of 1. So that's for today. I hope you like this video. If you like this video, please like, subscribe, and comment your thoughts into the comment box. And thank you for today.